Welcome to the Internet of Assets, the podcast about the not-so-distant future of finance. My name is Ryan King, Head of Business Development at Dusk, and every episode I will dive into a specific part of finance. We aim to do this in a maximum of 25 minutes. And in this episode, we're joined by the managing partner of Oak Security, Stefan Beyer, who founded a security auditing consultancy with a special focus on third-generation blockchains. And in this episode, we'll dive into the exciting world of blockchain audits. Welcome to the show, Stefan.
Yeah, thanks. Thanks for having me. Great to be here.
Can you give us a little introduction about yourself?
Yeah, sure. So, I think you gave a very good intro. I'm a computer scientist and I run a blockchain security company, which one of the things we do is audit blockchain software, but there are some other aspects to the blockchain security lifecycle. But I basically focus on anything to do with cryptographic and blockchain security.
Okay, great. Thanks very much. So as I mentioned in today's episode, we're going to talk about blockchain audits and also what role cybersecurity threats play in the field. But before we do that, let's dive a little bit more into background. So can you start by telling the listeners about your journey into the blockchain space?
Yeah, so as I said, I'm a computer scientist. So I did a degree in computer science in the 90s, which was followed by a PhD in operating systems. And when I delivered my thesis or read my thesis in 2004, the field of operating system was sort of at its end. Well, not at its end, but all the big research was done, and most of us, all the operating system researchers, moved into distributed systems. And that was, of course, pre-Bitcoin and pre-blockchain, but we did look at very similar things back then, like consensus protocols. We used to call things replicated databases instead of blockchains. Obviously, there was not the blockchain data structure, and we had different goals in terms of fault tolerance guarantees or fault tolerance models, failure models. But essentially, there are a lot of protocols developed back then, which are still around and still being used today. So I got into this world before blockchain even existed, and worked at a research institute as a postdoc. And at some point, Bitcoin came out. I think I heard about it relatively early in the grand scheme of things. Maybe not in 2010, but relatively early. But we sort of all dismissed the idea. I have to admit, in the distributed research world, we sort of dismissed the idea of replicating state on every single node. And we just thought that would never scale. And in a sense, we were right, because Bitcoin initially didn't scale. And, if it had taken off exponentially in the first few years, it would probably have failed in a sense. But I got more and more interested, but I also got interested in cybersecurity, got into a position in industry where I was the head of research of a cybersecurity company. And then at some point in 2017, after everyone realized that smart contract security became a big problem, I looked at combining the two fields, blockchain and security, and started offering, first as a freelancer, then founding my own company. I started offering services for auditing smart contracts, and then even layer ones and larger blockchain systems, anything related to blockchain applications. And in the latest iteration of this, we founded Oak Security in 2021.
Okay. Was there any particular experience or situation that led you to set up Oak Security?
No, I did work a lot with a company which we've since acquired, Solidified, which is our brand in the Ethereum ecosystem. And I really like the process, and we built on that. We can get into the process a bit later on, I suppose. But we work in a very specific way, and we thought there was a need for applying this type of process to newer blockchains, the Rust-based blockchains, things like Cosmos. Cosmos is written in Go, but there are a lot of smart contracts written on Rust, that run on top of blockchain, on top of Cosmos, Polkadot, these type of blockchains, they had a need of applying an auditing approach in a similar way.
Okay. Now, as I understand, Oak Security Course tends to focus more on third generation blockchains. In a minute, I'm going to ask you what was your inspiration for that. But since we have some fairly new people to the space who listen into these podcasts, would you give us a very quick rundown on exactly what the three generations of blockchain mean for anybody who's not familiar?
Yeah, I mean, it's essentially an arbitrary classification, but I think it's a good way of thinking about the different types of blockchains we've seen so far. Bitcoin is sort of the first generation of blockchains, Bitcoin and Bitcoin clones. So the idea was you had a cryptocurrency. And if you wanted to launch a cryptocurrency, you launched a blockchain. And these sort of were focused at replacing money, and some had little workarounds to build stuff on top, but they were mainly focused on cryptocurrencies, and they all had in common that they were not very general purpose and they didn't scale very well, and still don't. And then someone, Vitalik Buterin had the idea of, and some other people, to build Ethereum, which was essentially the first second generation blockchain in this classification. So second generation blockchains are general purpose. The idea here, there's a basic observation from moving from first to second generation, is that if every transaction moves balances around on accounts, or it's a bit more abstracted, obviously, but basically you're changing state. And that's essentially the same as exchanging state in a program, in a computer program. So if you generalize this a bit and you allow other things than just balance changes, you can make this general purpose, and you can essentially build on top of the blockchain pieces of software, which are smart contracts. So the second generation of blockchains, they now allow general purpose up to point, but up to point you can implement anything on top of these blockchains in a smart contract. But there was a problem. That didn't work very well because there's a limit on what you can implement in a smart contract due to the fact that everything is replicated on every node, and there's gas constraints and things cost money. So it's too expensive to build very complex systems. So the idea of the decentralized applications had a certain limitation. It didn't scale at all, or not very well. And similarly, there was no notion of interoperability, right? So you had one blockchain, you had another one, and if you tried to move assets from one to the other, you had to do very complicated things. And in the beginning, you couldn't do it at all, and now there's certain bridge solutions. But people start to think, how can we make this more interoperable, and how can we make it more scalable? And that's where third generation blockchains come in, which focused on sort of multi-chain scenarios like Cosmos does, where you have application-specific optimized chains that can communicate with each other. So there's interoperability built in, and also scalability due to the fact that, first of all, they tend to reduce the validator set to something that is manageable, and they can therefore use different algorithms. So they scale better in that sense, and they can talk to each other. So that's the third generation, focus on scalability and interoperability. And obviously, we worked on second generation blockchains in these smart contract audits, and saw the emergence of the third generation in parallel. And there's two things coming up in our heads. One is, obviously, there's a business opportunity, right? There's a new ecosystem. Nobody offers anything there, so we can be the first or one of the first. And there's a genuine need, right? Cross-blockchain communication or inter-chain communication introduces certain security risks that are slightly different to the earlier risks, and someone needs to look at this. So we found it interesting.
Yeah, indeed. So in addition to this, so let's talk a little bit more generally compared to, say, Ethereum or Bitcoin. What sort of challenges, in addition to the security one, were facing third generation blockchains that made you think, oh, there's a real chance here, there's a real need?
I mean, A lot of these things were sort of not immediately obvious to us. We just saw, right, that there's inter-blockchain communication, which is obviously new. So that's an issue. And we thought it's a new ecosystem, different paradigms. So there must be different things. And then we discovered when we started auditing things like COSM WASM smart contracts written in Rust, that the gas was incredibly cheap, the language was incredibly verbatim and verbose, and you could, people try to do very complex things in smart contracts that they couldn't do before. So the whole nature of what we audit in these third generation blockchains is often much more complex than on Ethereum. Another aspect that's unique is that, I was going to mention a third thing, but I forgot it now. But let's say the cross blockchain communication, the interoperability introduces a problem, and obviously the complexity of things. And that's the first thing we noticed.
Okay, all right, fair enough. I think that's actually a really good point. I think maybe not everybody necessarily jumps to that conclusion straight away. I think you explained very well there that since it's almost like since you can do more complex stuff, why not try doing more complex stuff? People often focus very much, like you said, on the scalability issue when talking about the move from second to third generation. But that's an extra issue. If you allow people more features and functions, people are going to use them. Right? If you allow people more freedom, they're going to try and do more stuff. Yeah. Which then creates, as you said, stuff you never would have spotted before. And I'm sure there's some other challenges as well that you spotted.
Yeah, that's. I remember now what I was going to say. The third thing, and it's very related to this. These blockchains tend to be more modular, right? So you have that you have Cosmos, for example, which is application specific. In each chain can be optimized to do certain things. That means there's a huge SDK where people can pick and choose modules and even extend these and do their own modules on their own blockchain. So that makes each blockchain within the Cosmos ecosystem slightly unique, which is also different to the Ethereum ecosystem, where if you write a smart contract, you can always assume the EVM, the virtual machine, behaves in a certain way.
Yeah, indeed, which causes then issues and then presumably some consistency issues as well over the whole thing, which have to be reconciled, I would imagine, as well. Yeah. So let's talk then about what the audit actually looks like then. So a blockchain audit. I think a lot of people out there, even people maybe in blockchain, have not really sat down to think what exactly is a blockchain audit? What would that look like? What's your usual approach to doing an audit? How do you get started with something like that? What's the process look like? Can you walk us through it?
Yeah. I mean, the process has evolved over the years, and we've now come to something which we believe to be quite unique. At some point, someone comes to us, hopefully relatively early in their development, and we can guide them because there are steps projects can take before an audit to make a project more secure. But at some point, there's a code base which we perform an audit on. So we look at this, we provide an estimate of time, and that obviously translates into a commercial proposal. But the way we deal with this code base is we first look at what do we need in terms of auditors. So we deliberately work with a large pool of auditors with very different backgrounds. So we don't only, they all have a technical background, of course, but we also employ some economists and people that have a slightly different approach at auditing. And we deliberately mix and match them, right? So we always employ a number of auditors on a single audit, and the way we match them is to make sure we cover everything the project needs. So if it's a DeFi project with a complex economical model, we make sure there's at least one economist. We also make sure the people working on audit have complementary methodologies. First of all, our framing, our main process is relatively lightweight. There's obviously certain steps every auditor has to do. But within that, they can apply their own methodology because, we believe that we've picked the best security experts that have a certain mindset and work in a certain way. And the way they approach an audit should be unique, right? We don't like hiring the best and then telling them what to do, right? So we let them do their work. And they work through the code in different ways. Some might be more formal methods, people that build a model and try to prove things. Others are very test-oriented. They might look at the economic model, define certain cases where they think fuzz testing makes sense and apply invariance to this and run fuzz tests. And all of them obviously go through all the code manually. And the way they work internally is in a sense, they compete with each other, right? They don't share their findings. The guiding principle is every line of code has to be looked at by 3 people. And they don't share their findings to each other. They do, of course, talk. They discuss design, architecture, and things like this, but they don't reveal their findings to each other. And then there's a consensus meeting where they share their findings and put them together into a report, which goes to the client. Now, obviously, the process is designed with certain purpose, but the main thing there really is they don't bias each other, right? They work independently because it's very easy to convince yourself there's an issue if someone points you to it, and that leads to a lot of false positives, and we've managed to reduce that. And also, we believe everyone working with us works very seriously and doesn't leave things out. But it's easy to subconsciously, skip over a part that is very difficult, or trust that someone else will look at it more carefully. Even if it's very subconscious, it can happen. And if people are in a way competing, they're sort of motivated not to do that. Nobody wants to turn up at the meeting having missed an important issue, right?
Indeed.
And the third part is obviously quality control. We can detect if someone misses a certain type of issue repeatedly, and we can train them accordingly. And similarly, if we have a lot of overlap, we know that the audit is doing well in a sense. And obviously, the client gets a report, right? And the whole purpose of doing an audit for a client is to get external eyes that look at the piece of code with different mindset, right? So first of all, needs to be someone who's not too familiar with the project. Obviously, you familiarize with the project, but having a completely fresh attitude or sort of finds a lot of conceptual flaws from the start, right? So that sort of helps a lot not to be involved with the project. And also it needs to be someone with a certain mindset. So the people we employ that don't necessarily the best developers, but they are the best at breaking things, right? So we've noticed repeatedly that people that are really good at auditing are not necessarily good at building stuff. It's not exactly the same mindset.
Okay, it's time for the unpopular opinion. So, Stefan, what is an unpopular opinion that you have about the current blockchain space?
Okay, so my unpopular opinion would probably be there are a lot of silly projects and things like the current situation where there's not too much money flowing into the blockchain space. The bear market helps a little bit of sorting out these problems, right? So when during a bull market or let's say the NFT craze we last had a year and a half ago, we got so many projects that were implemented by people that didn't really understand crypto, were in crypto for the wrong reasons, and they were of poor quality, both from a security point of view as from a conceptual point of view. That didn't make sense. And the unpopular opinion, even if it might not be too unpopular, is that the bear market actually is good for this, sorting out this type of problem. And there are, in general, bear market, bull market, or whatever, there are a lot of ideas being implemented in crypto projects that don't make too much sense, right? They're silly ideas, either translated directly from traditional finance or new things that are just there to make more money. And I'd actually like to see some non-financial projects, to be honest.
Yeah, indeed. Okay, thanks very much. That was the unpopular opinion. So I'm sure there's been a lot of very interesting cases that you've seen over the years. Do you have a particular case that you'd be willing to share, something that stuck with you, something that was very special or interesting?
I mean, there was a recent case where I don't I prefer not to name the projects for
Oh,
legal
absolutely.
reasons, obviously, but there was an exploit and something we had audited before, and we looked at what happened and we realized, well, this part of the code we've never seen, right? So we sort of was a relief for us because we were not to blame in any sense. We hadn't overlooked anything. But it sort of brought home the fact that a lot of projects evolve over time, and they just added a single line of code which completely broke the thing, and that happens a lot. And then you also get into things like you get thrown into war rooms where you obviously, even if you're not at fault, you're trying to help your clients, right? Because these are people you've developed a relationship with, and you need to sort of get involved. And it brought home the idea that there's a big difference between running a project and then deploying it and afterwards dealing with it, right? So give you an example. Most projects to protect themselves from regulatory things, they say we produce a software and then we give this to the world, and then there's a DAO, there's governance, the users own it, right? But then you have an exploit, and in this particular case, the company started negotiating with the exploiter. And at the back of my mind, I was, thinking, there's a big legal issue there. Why are you negotiating if it's not your project, right? So you're claiming in front of regulators that you've sort of that you're not in charge of this, but it's essentially it's other people's money you're negotiating with, then, right? So that the most interesting cases are these where things go wrong, and then you learn something from that.
Indeed, that's an interesting. We have a lot of discussion on this show about legal elements and compliant elements, so that particularly appeals to me. Off the top of my head, I've forgotten the Latin phrase. I must admit, but there is a phrase for this where you can be deemed to be responsible by your actions, even though there is no legal contractual definition that you're responsible. So basically, acting like a director makes you a director, even though you're not legally a director, kind of thing. This happens in company law all the time, right? So that's a very interesting case. Yeah, it's almost like going into those negotiations, they've actually very seriously weakened themselves legally just by doing that. But then the counter is, what could they do? Nothing. It's a very difficult position to be in, isn't it?
Yeah, it is. I mean, it's one of the unsolved problems, I suppose.
Yeah, indeed. Okay, I found that very interesting. That's very cool. To make this a little bit more practical for people listening in, because we have people listening in also who are sort of just getting started. They're just coming up with some ideas, or maybe because we talked before about a lot of ideas coming out, things that need to be thought through. What do people need to do? What do builders need to do? What do they need to think about more before getting started? What would you recommend specifically to help them prevent running into vulnerabilities later on?
Yeah, I mean, so audits sit relatively close to the end of the process, but there's a lot of stuff that can be done before, which we call sort of a shift left security approach. Because everything moves earlier, right? So the first thing, projects, if you have an idea for, let's say, DeFi project, because that's the most common case. The first thing to realize is that DeFi is financial software. Financial software is critical software. So there are two things here. You need someone on the team that knows about critical software, right? So you now need to approach it like a spaceship launch rather than a mobile app launch. That's one thing. You have to realize it's critical software. And then because it's financial software, you need to realize that you need someone with finance expertise. It's quite amazing how many developers, people with a computer science background, really good developers, think they suddenly have a great idea for finance and then get a model completely mixed up. And at that point, I think it makes already sense to talk to security experts like us or similar companies. And there are some that specialize on these early stages even more than we do. And then you have to think who you hire, right? So the world of blockchain is essentially very decentralized, also in a geographical way. So you get a freelancer from the other end of the world to write some smart contracts or other critical software for you, and expect that to be free of errors and backdoors, and you don't even know who you're dealing with, really. So that's, how to build your team. That's already very important. The development practices you have there, who gets access to what, how are things stored, then how do you test out things, how you deploy things, how do you manage keys internally, what processes, what policies are in place when keys get compromised, how do you revoke keys, how do you deal with someone leaving the company. All this is very important. And then when it comes to the actual coding, if you use something like Solidity or any other framework language, there are certain foot guns, things that have gone wrong in the past and are easy to do. So you have to learn from these, and there's software you can use to detect this. Right? So if you're using Solidity, there's absolutely no reason why we should get in an audit very basic things that could be found with a static code analyzer. So there are a lot of things you can do as a team to make your code more secure. Have internal reviews, have certain things built into your developing or release schedule that can only be committed, or pull requests that can only be accepted when certain tests pass. Think about testing from the beginning, of course. That's very important. And maybe get someone involved who can set up fast testing and things like this, define invariants correctly so that you can automate things with software. And then, talk to us as early as possible, or anyone else in the security ecosystem.
Yeah, very logical choices. A lot of it's coming back to good old-fashioned concepts like fail to prepare, then prepare for failure, right? I mean,
yeah. I mean, one important aspect we prepare for failure is, some projects, when they get exploited, which can always happen, they don't have any procedures in place, and they sort of panic.
Yeah.
And if you have like a worst case scenario case that you play through, and you have procedures written up, what to do, create a forum, get these and these people involved, reach out to this and that one, and block this, immediately revoke these keys, and certain things, and how you communicate to the community. If that's all sort of prepared, it makes it much less stressful. Still stressful, but it's less.
More less unknowns, I suppose, or at least you have
exactly.
no sitting around thinking, what are we going to do? Because you know what you're going to do. You have a process ready to go. Yeah. That's fair enough. Like all emergency procedures, right? This is the same reason why we rehearse things like how to escape from a building on fire, right? So you don't want to be thinking about that while the fire is going. You don't want to be thinking, which door would be the easiest to get? You don't know. There's no time where you just have to go, right? So,
I mean, also, things like there are a lot of debates on if a DeFi protocol should have a big red button for someone to press when things go wrong to halt everything. That's a completely separate debate. But if you have such a thing, you have to prepare to know when to press it. And a lot of projects don't press it until it's too late. So that's also, prepared in a way, but you don't have the procedure in place to deal with it.
Indeed. Okay. Now moving on to the industry in general. So it's evolving a lot. We talked already about generations, but even within third generation, there's so many different variants, and then you've got layers, and it's an industry that's just moving at a breakneck speed. How do you keep up to date with all of this?
It's not easy to keep up to date with things as a single person, but that's why we have a team. We have people that are extremely knowledgeable in Rust, and they follow anything related to Rust. We have people that are very keen on a certain blockchain, and they follow that. And then they're also very good at sharing this knowledge internally. I have to admit, as the manager of company, and there's two of us, we are two owners, and we sort of used to audit ourselves, but at some point you have to step back and delegate. it's sometimes frustrating for me to to not understand some of the latest exploits immediately, because we are doing other things like invoicing, admin work, and stuff like this.
Yeah, I can imagine. There is this tendency to want to understand everything. I get that, but you have to have good people to rely on, right?
I mean, what we have noticed is that we cannot have. I mean, we have some people that we can move around the company in different positions, but most are relatively specialized. You can't be an expert on certain parts of the EVM and at the same time understand everything or related to the Cosmos SDK blockchain implementations, right? So it's just too much to follow for a single person.
Yeah, indeed. Well, if we look at the future then, because there's going to be obviously much more evolution, new things coming out, changing the industry. We've got regulations coming in, especially here in Europe. Do you have any feelings for where you see the industry evolving in the future? Any predictions or any general trends you can see emerging?
I think, I mean, we've already noticed that we get more requests from projects preparing for a regulated DeFi scenario.
Right.
And I think that there's going to be a difference in different jurisdictions. Some will be more open to certain type of things, but in a regulated way. Others will try to prohibit certain things. And that's going to be challenging because, it's been for a while now that you can't do certain things in the US that you can do in Europe. And I'm not sure that's the case vice versa, but there might be certain things. But regulated DeFi is going to be a trend, I think. Things like identity on the blockchain is being pushed aggressively, I think, or quite actively within the European Union. So we might see things like verifiable credentials behind DeFi applications. So that would certainly be interesting from a technological point of view. And it also has a lot of non-financial applications. And other than that, it's difficult to say in terms of trends. There's obviously privacy and scaling, which for technological reasons go hand in hand. A lot of what is good for privacy is also good for scaling. So there's an open question mark on how can we have private transactions in the presence of regulatory frameworks. There are certain things that can be done and probably will be done in the future. So that's certainly going to be interesting.
Okay. Thank you. Thanks for sharing that. And finally, what's the long-term vision for yourself and for Oak Security?
So Oak Security, our long-term vision, and that goes for myself, obviously, is to grow responsibly. We've done that in the past. We've had the opportunity to take on external funding to grow more quickly, but we've noticed there was not enough talent available on the market to do that well. We've seen other companies grow quickly and then drop quality, in my opinion. And so we want to continue growing, looking at new ecosystems, things like privacy blockchains or CK stuff would be interesting for us. But it's difficult to see where that goes. On the other side, we are actively shifting everything left. What I've mentioned before, shift left security. So we, in the future, want to get involved earlier, much more. We already have a lot of clients that reach out very early. We would like not just for our business, but for the ecosystem in general. I think it would be good for the industry or the ecosystems to realize that they have to think about security very early. And we are also actively researching tooling. So in the future, long term, we see ourselves as a relatively big security firm that has grown organically with a focus on the whole security pipeline. That's sort of our goal.
Okay, very clear. So today we've had the opportunity to talk about some of the unique features of third generation blockchains that have created opportunities and needs for better security audits, such as the security risks that come about for inter-blockchain communication, the invitation to do more complex things in smart contracts in third generation blockchains, and the modularity of those, creating these sort of interesting scenarios. We've talked a little bit about what Stefan calls his shift left approach for people getting started. So getting and thinking about these security things earlier on, such as accepting that this is critical software and you need somebody on the team who knows critical software. You need somebody on the team who knows finance. You should speak to security experts early on. Think about who you hire, learn from the mistakes of people who've used the languages that you're using before, and test from the very beginning. We've also talked about Stefan's opinions on trends for the future. He sees a lot of growth in areas like Reg DeFi, identity, and the simultaneous development of privacy and scaling. And I had a lot of fun talking about these topics today. Many of them fit, of course, with what we do at Dusk and what I do personally. So it's very interesting for me. Thank you so much for coming on today, Stefan.
Yeah, thank you for inviting me. I think that was an interesting chat.
It was a very interesting chat, very interesting for me. So I had the pleasure to talk once again to Stefan Beyer from Oak Security. My name's Ryan King, and this was the Internet of Assets, the podcast about the not so distant future of finance. Thanks for listening.